I was never great at math.
I saw you have around 8 patents, right? What was that story?
You ever prove to an investor you're going to return 10 crores or 20 crores of funding back to them?
What does your tool help the players do better?
You take a batter like Rohit Sharma. How did they play a short ball? How did they fare against balls that came on the offside? So maybe against all off spinners. I think the biggest challenge I see with candidates is the fear of missing out. So they know a little bit of everything. That critical thinking is coming down. I would love to work with people who are not over dependent on vibe coding. This is a big danger I'm seeing in the new hires.
Welcome back to the Beyond the Byte podcast. Today we have Mr. Shankar with us. Shankar is the CEO of one of the leading sports tech startups in India, BanyanBoard. Beyond that, he is someone with phenomenal experience in the industry, starting from a background in material science. He has been a part of teams and leading teams across GE, Aditya Birla Group and beyond.
Hi, thank you for having me here.
Thanks for making it. So, you are someone whose journey has been in various layers. So first I would like to go into the interesting part, which is you started off as someone whose pedigree was in material science. So how did you navigate it from there to being someone in data science?
Yeah, it didn't happen very planned or anything. I always enjoyed working with software. So when I was a material science student, I was an experimentalist, but we always had to write some code to figure out how to get more out of the data. So I did not realize I was doing data engineering or data science back then. And in material science, the issue is it's very expensive to do engineering, really. One sample would be very expensive, one experiment would be very expensive, repetitions would be very expensive. So you try to squeeze as much as you can from the data. So I think all of us, everybody, not just me, all of my colleagues, my professor, everybody was always trying to squeeze more and more through code. So you try to reduce noise, you try to use statistical methods to not have to do more work and prove statistically that you're doing the right thing. So that's how I think some sense of data science got in. Then when I worked with GE had in their the whole scheme of things, everybody had to do something called a Six Sigma training. So Six Sigma is essentially just a bunch of collection of statistical tools. Like for example, most people would not know about what is hypothesis testing. So they would teach you what's hypothesis testing. They would teach you how to build a linear regression model, how to build what is ANOVA, and so on. So you come out of it with at least common terms that you and your colleague, if you're doing an experiment and your colleague says, I don't agree with the conclusions of the experiment, you have a statistical basis to have a good argument. And we used to use a software called Minitab. And Minitab, I don't know, it probably still exists in the market. It's not a very easy to use software. So I would try to always avoid using Minitab and just do everything else with Excel, or at that point I was not even good at Python. So that's more of data science work with GE, largely hypothesis testing, and you all had to do a project and you had to prove you understood through the project. Turned out that my project was actually a good one because I was using it to prove that we'd invented something that was statistically relevant, that the company should put more money to actually use what we've invented. So for that, you have to do some statistical analysis. Like I said, materials always was even is now a very resource intensive field. So now, you can do 30 experiments in materials, so maybe equivalent of 300 experiments somewhere. But within the 30 experiments, how do you get enough statistical evidence to convince management? So we did all of that. So maybe I got trained a little bit more there. Around 2016, GE had a lot of push in statistical methods, turning into machine learning methods. Some of it was just jargon, same things were called machine learning, but some of it was real as well. They were just pushing all the people to start learning more about machine learning, and they were offering some resources and all that. So I was figuring out, what do I do? And I just went to the chief statistician of GE Research. Her name was Martha Gardner. And I just asked Martha, what do I do? There's so many things out there to learn. Even back then, I mean, today it's exploded even more, but this 2016 is enough to learn, and enough that free stuff. Coursera was just coming up. And then I really am grateful to Martha for that suggestion. She suggested I should look up a couple of professors from Stanford. They were called Trevor Hasty and Rob Tibshirani, giants in the field of statistics. I had no clue that they were giants. She just said, just go to their course. It's free. It's taught in R. And by the time I did enough scripting around with several languages, R was not uncomfortable, but neither was it very comfortable. But R was free. And so that was the reason for choosing R. And I did that full course, and it was tremendous. I mean, the way they taught was tremendous. Neither did they go too deep, neither were they too shallow. The questions at the end of each session was tremendous. And it so turned out then because of some career choices, I wanted to move back to India. And at that point, I was still in the US when I learned about the Stanford Introduction to Statistical Learning course. It is still available. Stanford has moved it to a portal called EDX. It's still available on EDX. In fact, the course itself is available on YouTube. But if you want the questions, you go to EDX. So anyone is welcome to still use it. At that point, it's still just getting to learn how to build models. It was still not, I wouldn't call it machine learning that deep or anything. But when I had moved back to India, through some turn of events, I was placed in the GE digital arm. So directly from materials engineering, the only role I was immediately able to find was in the GE digital wing. And we were selling products to the Indian market. GE was selling a product called Predix, which was to help industrial Internet of Things blossom. And a lot of industrial analytics was supposed to be placed in this platform called Predix. So we used to sell asset performance management, which is largely during anomaly detection in a time series, a multivariate time series, and you've got to do anomaly detection. So I was not building anything. I was a salesperson. I turned into a salesperson because this role was such that the deal is, you had to learn something other than what you already know if you wanted to be a part of this program. It's called an accelerated leadership program. So I said, okay, that's very interesting. I have never done sales. Let me get into it. But through the process in India, we had no pre-sales support. So pre-sales helps sales make the sale, right? Pre-sales are the technical guys. And for almost every other call would land up in Chicago or some place in the US because they were just staffing the team, or India was not a priority market at the time. So we didn't have sales support, but I was a techie. So I said, okay, let me just go learn this up. I would pick up the manuals, read up the algorithms, because I didn't want to sound like a fool in front of my client. And the client doesn't care whether you're a salesperson, pre-salesperson. They just want the question answered. So at that point, I was selling to Jindal, Mahindra, Tata, Indian Oil, Vedanta. So big clients, people who knew this stuff, and they had, each plant was worth 1,000 crores. So big machines, a lot of investment. So they're not going to invest in a piece of technology where the first dialogue they have with somebody that they don't even know what they're talking about. So that got me a lot deeper into time series. In fact, that got me very deep into time series. I really wanted to understand what is a multivariate time series, what is state of the art. I called up all my friends, a lot of people in GE I knew. My brother included. I have a twin brother who's very good at time series, and I called up all of them, asked them, what is this? What is anomaly detection? What are the state-of-the-art algorithms? And that is when anomaly detection itself was having a revolution. A lot of people were thinking maybe you could do it with neural networks. So some people were trying neural networks-based techniques. Some people were trying other techniques. So, and then when I was doing all of this, I got an offer from Aditya Birla Group to lead 3 of their group verticals that they were starting a centralized data science team in Bangalore. And somehow I didn't even think I was cut out for the role, but they felt, given the background I was having in selling these sort of analytics-driven products in the ecosystem of manufacturing, that it might help them because they were a very manufacturing-heavy company and they were trying to adopt analytics in manufacturing. So I joined them. I worked on their chemicals business, their specialty chemicals business, and their carbon business. Briefly also worked on the textiles business and also their trading business. But largely the problems I was touching were time series problems. We used to do time series forecasting, time series anomaly detection, and so on. And then I had a lot of friends, on the floor who were simultaneously doing natural language processing. Somebody was doing computer vision. A lot of product was also getting built. They wanted to build products and sell products as well. So it was suddenly an enormous hands-on exposure to building stuff, because it was not just consulting. We had to build and prove it could be worth it and hope the internal businesses kind of adopt what we do. So within a very short span of time, just because of this role with GE where I had to sell analytics as a product, I kind of got sucked into analytics. And then I started on the side. I wanted to build stuff because I didn't. know what we were selling. So I used to build small projects in computer vision, small projects in anomaly detection, with whatever my Dell laptop would permit me to do. And that was important to learn transfer learning. That was important to just see what would unsupervised clustering do in an anomaly detection sense for time series. So that's kind of how it was not a very well thought out move into data science. I think it's probably the market kind of pulled me, because the Indian market, I think, had a lot more data science jobs, and I could not find any role meanwhile in material science either. It's not like I was willingly looking to get out of material science. I really enjoyed material science. I still remember everything I'd done because I truly enjoyed what I did. But the Indian market does not have deep tech jobs in material science, not too many of them. So I kind of said, okay, it was priority for me to stay in India. So I said, let me move towards something where there is value. People see value in what I do. I enjoy it. There's a lot of tech in data science. You always dissecting what you want to do. You feel at home. I feel at home when I'm doing stuff like that. So that's how I got into data science.
So in your initial days, number one, what was your first programming language? And next, as someone who did not have a formal training in computer science, like I'm sure you may not have had a data structures course somewhere, right? So what were the difficulties you faced? Because for you, it was not building an algorithm. For you, it was taking an algorithm and applying it for your statistical analysis. How was that in the initial days? And how did you build yourself to a space where you had to get the job done irrespective of the tool? How did you get into that mindset?
Fair question, yeah. So the first ever thing I learned was BASIC. This was in 8th standard, and near our house, there was a small company that started, like Byte Excel, but they were teaching kids at that time. And it was walking distance. So our dad said, summer holidays, don't waste your time. Why don't you go there? And my first teacher, I'm really feeling bad. I suddenly can't recollect her name. She was the best computer science teacher I ever had. And the way she would teach us, there were 3 students, me, my brother, Sham, and then one more student. We don't even know who it was. And she would just teach us BASIC. But the way she would walk through a for loop or if, while logic, if else logic, while do logic, and you just opened your eyes to what is the art of possible. And that was really, I think, we became very, very interested in computers at that point. And then in school, we learned Fox Pro, and we did not even learn C, C++ because my school had decided not to teach C, C++. They had decided to teach Fox Pro. In college, first year we learned Pascal, and then everybody had to learn Pascal, so I learned Pascal. I did decently well there, and then going on, one of the professors who taught us computational material science, he taught it in Visual Pascal Delphi. So he asked us to code it up in Delphi, and that was his favorite language. And I did that. Along the way, we had to do some work in Visual Basic for Excel. All of that happened. In PhD, I did a lot of work in MATLAB, because a lot of image processing. I used to work on transmission electron microscopy, which is a lot of image processing. So MATLAB was really and we had a license from the university, so it was easy to get that MATLAB toolboxes going and all of that. Then we used to heavily use a scripting language called Gatan Digital Micrograph. The reason I'm walking you through all this is none of it was planned, and I feel sometimes when I talk to some of the students these days, there's a lot of worry in their head about, hey, I'm not learning Java or Python or whatever, Flutter or whatever, will I get left out? I don't think, once you know one language, you really get left out. You slowly develop that flavor for whatever is the current language of choice, and you move towards that. So maybe tomorrow it's Rust, day after tomorrow it's something else, who knows? So you're going to move towards that. And the Gatan scripting language also taught me a lot about what is the value of scripting. Certain languages are not great at being generalized programming languages, but the language was very good at handling electron microscopy images. It got me my first publication, so I am I'm very happy about that language. And then got into R, got into Python. But over the course of time, I think that's when you asked, right, how do you get in the mindset to just choose the language that you want to get the job done with? I didn't have that problem because I was never a language specialist. I was not hired for a C, I was not hired for my Java skills. I was hired to do microscopy analysis. My bosses didn't care what language I used. Similarly, once I got to Aditya Birla, where I had to do data science on a day-to-day basis, practically code every week there, and nobody cared what you use. As long as licenses were okay, you're not violating any licenses. You can do whatever you want. And once I started BanyanBoard, it's there. I mean, we've been a little bit more focused on doing only a few languages because here we're a small company. There's a choice. Doing data science as a consulting gig is different from doing data science as a product, because once you choose a product, the team has to come around the language. So if you make a language choice, your team can't work on a different language because it's a product, right? So here we made some choices, like we do everything in the back end with Python and everything on the front end with React. So those are just choices we've made, and we may change those choices later, but that's because we're a product company now. But historically, since we're not a product company, I would just do whatever I want. Yeah.
So in your journey, do you feel that since you had a pretty strong academic background where you were initially into research, I saw you have around 8 patents, right? Do you think that paved also a role of you being able to successfully not only pivot to data science, get into machine learning, but also succeed in that? Or do you think at this point in time where there are students entering into multiple undergraduate programs, how much role does math play still in this area?
See, actually, I find it a little difficult to answer that question because I was never great at math, but I was never bad at math either. I would just treat it as something if I really need to learn, I would learn, but it's not something I enjoyed. It does help to be good in math because, I just find it very hard to learn things if I'm not deep in any subject. It could be material science or data science. Now I do software engineering for a living. If I don't understand the philosophy, the fundamental laws that govern the ecosystem, I find it very hard to go deep or do anything innovative. Innovation, I think, requires you to do something that somebody else has not done, for which starting from first principles helps. So for that reason, I think if somebody is doing data science, it is helpful to do math. It's at least you should consider doing math. If you're finding it hard and if you're finding it something that you want to avoid, then certainly, like for example, you can probably struggle to innovate on next architecture of a neural network. I'm saying it's a very deep problem. You may not even be asked to work on it, but at the same time, there's so much you could do around data science. Like for example, even data engineering doesn't require math. Even within data science, a lot of good data science comes down to intuition. So if you understand the domain, so for me, the reason I got into data science was I understood materials engineering. A lot of it came down to intuition about how the domain works. So if you're in medical domain, you may have some intuition around how the heart works, and that could contribute. So you don't have to be really math heavy. So I do think the super math heavy, brilliant people have a niche, which obviously others can't touch. Similarly, people like me who are okay with math, we will use math when we want it, but we're not like craving for more and more math, have a space. And there are also people who really hate math. They also have a space. I think there's a large enough space for everybody to... It's a spectrum, yeah.
So I wanted to know, in your journey, when did you decide that you want to start your own venture and that's going to be in sports analytics? What was that story?
Okay, so that was also not very well planned. My goal was to just come back to India and help contribute to tech development in India, because I just felt we've grown up on Indian tax dollars, right, or Indian tax rupees. It's not fair for us to just not come back and contribute. And I wanted to contribute at a reasonably young age when I still had some energy to work long hours and all of that. But unfortunately, when I moved back, I realized that materials engineering was a very high investment field. And I was a research scientist. I was always in the lab. I was always reading papers. Even on vacation, I would read papers. I'm not even thinking about investing or what is capital or what is how do you make a company. None of those thoughts ever entered the mind. But once I talked to investors and they asked me basic questions that I could not answer, like how long will it take for you to return the capital, I did not even know how to start answering that question, forget answering the question. So then I said, I got to learn a little bit about what is building a company, right? If I'm going to ask somebody for the money, then I started learning about what is money, how does investment work, what do they expect? And then I started feeling a little afraid, because if I'm going to take so much money from somebody and they're asking me for 6 years before which it will be returned, how do I guarantee if I don't have clients? And then where do I find clients from? And then all the chess calculations of if this happened, then that would happen. How will you ever prove to an investor you're going to return 10 crores or 20 crores of funding back to them? So that got me very confused when I started looking around in material science. I just said, stop it. I'm not going to ever start a company. And this was around 2017 or 18. After I moved back, I said, it's just never going to work. And I went back to working for Aditya Birla and continued there. But once I was in Aditya Birla, my real hope was joining them. They were big, conglomerate, billions of dollars of revenue, and they'd put their energy into thinking about products. Over time, I realized big conglomerates, Indian conglomerates, are finding it very hard to do innovative work because they're public companies. And public companies have constant quarterly pressures of returning investment to their, by the time I understood investing and I understood share markets, what public markets expect and so on, I was investing myself just to get a feel of the markets. Then I understood it's going to be very, very hard for somebody in a public company in India to do very deep innovative work because your investors will not let you do that. But if you're going to invest 5,000 crores in a big plant and going to return 5% every year after that, your investors understand that, they'll let you do it. So that was the real impetus for me to start thinking about building my own company. I told my brother about this, and these are kind of confusing thoughts in my head. Nothing was very clear at that point. Then he said, hey, you're talking a lot of the language that I keep hearing from this very interesting founder called Sridhar Vembu of Zoho. He said, why don't you go listen to him? So then I went and started listening to him. I started listening to his first talk, the second talk, and then many ways I felt I was thinking the same thoughts he had, but I just was not able to crystallize it the way he was able to crystallize it. And a lot of it crystallized in my brain. And one of the crystallizations I had was, one, I wanted to do deep research. And for me, deep research was supposed to be my calling, and that's what I wanted to do. And to do deep research, you need a lot of time. Right? You can't buy time with money. Right? If I go to investors, and what do investors expect? They expect exits. So I was thinking, how do I solve all of this? And so he had laid out a plan for bootstrapping a company, and he walked through his plan for how he would do it. And he did it as well. Him and his brothers and his friends did it. So I said, okay, this plan I could work with. And for 2-ish years in Aditya Birla Group, we had a wonderful group of phenomenally talented people. I also developed a lot of confidence in building software, just being around them. I never built software, but just being around them, knowing about what's React. I was so bad, I didn't even know what's the difference between React and Node. So 2021 I started the company. 2020 I did not know the difference between React and Node. I asked somebody, hey, they say React JS, Node is also JS. What's the difference, right? And he just glared at me and he said, you're in data science? Yeah, I am. But you don't know this? No, I don't know any of this. So, but having a ecosystem of friends, people who are knowledgeable, that was helpful. So 2021, when I was explaining to my brother all this, he was very deep in software himself. So he was building software for controlling large batteries, him and his team. And so he explained a lot of things as well. So that's when I decided, okay, I can keep thinking that some big conglomerate with a lot of money will invest in deep tech in India, and maybe I'll keep being wrong, or I can try it on my own. So I said, let me just try it on my own, and I quit. I did not write one line of code before I quit. After I quit, then I did a lot of research, talked to Sham, and then we figured out what will be the stack, and even which product, right, which market, and everything was done after we quit. And the problem became, it is not the right way to start a company, by the way. So if anybody is looking to start a company, it's much better to know the market you're getting into before you quit. But people like us who are very committed to the company, even the weekends we would think about company work. It's very hard to get your mind out of what you're doing in a day-to-day job because trying to solve problems for the companies. The only way to do this was to quit and then start thinking. So the first year I built a product called Collab. BanyanBoard had a product called Collab. What the idea was, people could draw on videos. So today you have WhatsApp. It's very easy to annotate a WhatsApp and send it across as an image. But you still can't do it on a video, right? If you want a video editing software, you either go to, After Effects or Premiere Pro or Canva, something like that. Right? But it's still, it's not trivial. I can't ask my mother to do it, for example. But I can ask my mother to annotate, WhatsApp image. Even though she's not very deep with computers, she can easily annotate a WhatsApp image. So that was the product we conceived, and it was high end of COVID. This was mid 2021 when I quit.
Stack you used for that?
So React on the front end, Django on the back end. Right, the React was the drawing part, right? So we built it. It still exists, and the idea was it'll help people teach better because people were shipping a lot of videos for teaching, and there's also a lot of shipping of videos going on for software development. The product manager is sitting one place, the developer is sitting another place. The vision is not getting met. We were also looking at special effects, people who are doing movies, movie making, feedback on videos. So we knew it had a huge potential, feedback on videos. But Of course, we were developing software for the first time. Even now the UI sucks. Even now the whole, it's very clunky the way we built it. But it works, it's functional and it works. We use it even every day today. That's how we give feedback on our product features. Yesterday, before I came here, I told my team this is what we want to work on for a social media post. We recorded the screen and we annotated and we left it. It's functional, very useful, but only sports was already doing this. Everywhere else, I was convincing people. I was saying, I went to researchers and said, and in research, I was a researcher, so I knew this would work in research, because in research, you're spending $5 million to do a large program. $2.5 million would usually be you reinventing the wheel, because the last person who did it would have just written a report. And it's very hard to understand, especially domains that are very media rich, like material science or even medicine. What do you mean when you read a report? So if you look at Wikipedia even today, 90% of Wikipedia is text, 5% is images, or like maybe 10% even, right? So we think that is just the wrong way to learn. I totally think it should be, at least for example, in domains like materials engineering, 90% of the content should be images annotated with text, because the image has the real depth of meaning.
There's 1,000 words.
There's 1,000 words, right? But there's no tool to do that easily. So this is what we were promoting to researchers. Nobody bought it. Not even a single person bought it except ByteXL. So that's how I got in touch with ByteXL, because Karun really saw the power, because we talked about a complex equation. You have a numerator, denominator. On the numerator you have some exponents, denominator you have an exponent. Teacher is teaching. The teacher is thinking, I'm pointing to the exponent on the numerator. The student is probably looking at the exponent of the denominator, because you don't have easy ways to annotate. But your video would just have the equation. So each teacher, when they're teaching, could we have some call-outs, annotations, etc. That was my first pitch to ByteXL, and Karun bought that idea. But it never took off. And sports, I was really not having even one client after 1 year. I was at my cousin's place and I was really lamenting about this. He is an ex-basketball captain in the Tamil Nadu college days when he was a college player. So he looked at it and said, have you tried sports? I said, I've never tried it, but I would be happy to try. He said, okay, come tomorrow. Just come with me to my son's game and I'll show you the organizer. Talk to the organizer, just figure out. And, again, if you read about how to sell and all of that, this is a good way to sell, but I should have done this 1 year back, like 1.5 years back, before I decided to get into the domain. I could have done all this research, but I was a techie, no background in how to do product market research, all of that. So then I went to this tournament organizer. I showed him what I got. Then he just looked at me and said, have you heard of Huddle? Huddle is a big company. It's #1 in sports video analysis in the world. And he said, have you looked at them? I said, no. He said, maybe look at them, then come back and talk to me. But he said, yes, this is useful in sports. We could potentially use it, then come back. And then that's how the research into Huddle started. And then we said, oh, they built exactly what we built, except it's for sports. And immediately we flipped the switch, because I'm also a big sports buff. I love playing a lot of sports, and we could clearly understand why they were using it. Talked to 3 or 4 people, and then everybody said, yeah, sports, we use it. Then Sham had just moved back to India, and he was just starting to be full-time in BanyanBoard. So we said, let's just jump into a field where I don't have to convince somebody to use it. We may have to compete with an incumbent. And, again, very naively, initially, we wanted to be in a place where there's no competition, right? Everybody wants to build in a place where there's no competition. But we've realized now that's never a good place to build in. The best place to build in is where there is competition, because then you can talk to the client and say, you're using this product.
You have to teach the market.
You have to teach the market, and it's much easier for them to make a mental switch, right? So that's how we got into sports. And then once we started doing that and we started looking for places to compete, initially we had 1 feature. Now we probably have, if let's say Huddle has about 100 features, we probably have about 80 of them. But fundamentally, in a way we are lucky. The product Huddle is a desktop product. They've not migrated like natively to the cloud. They have some cloud versions of it, but natively it is built as a desktop product. They never wanted to, I guess, move on. So we said, okay, that's a good place to compete, because we have a fully cloud product. We will natively make it cloud with a very similar user experience. So we built it from scratch, and we call it SPAN, sports analysis, and that's how we got into sports. And since sports is something we love, I mean, we may not have done this if, like, for example, it was something like fashion. I don't understand ABC of fashion. I may not have seen that opportunity. It may have just passed me, because we understood sport. Then we said, okay, and we had the tech, this sort of real-time collaboration, tagging. We were doing complex annotations. Sports didn't even need that much, but they needed different, things. But why I mentioned this is, again, if somebody is looking to start a company, I still think any sort of time spent in research is useful, because the first 1 year really solidified our stack. Back then, we did not have Kubernetes. We did not have 99.99% uptime guarantee. So the one time I got one client, the first client in football, we just had a single server on DigitalOcean, and we had to run an update. How do you run an update? You take the server down, and then we didn't even know how to do a hot update back then. So I took the server down, pushed an update, turned it back on. It turned out exactly the time my client wanted to test it. The client never came back to us after that. So you learn the hard way, right? And then you learn, okay, what's the value of the time invested in Kubernetes? And what is the value of time invested? Because it took us 3 months this is pre-chat GPT. So it took us 3 months, and neither of Sham or myself knew Kubernetes. So the first thing he did after he came back was to set up the full Kubernetes cluster. I mean, knock on wood, there is no wood, but till now it has never gone down after we've done that, because there's enough redundancies and all of that. But the research is useful. So, and since both of us come from the R&D mindset, we do find any sort of R&D you do, as long as you're keeping that mindset that, okay, I'm going to use it somewhere in the future. All the React R&D, the Django R&D, the Postgres R&D, I mean, I say R&D, nothing very deep compared to what others know, but for us it's new. And you can't buy knowledge, right? You have to learn it by yourself. So for us, all that went into the sports. And the advantage with the sports then was we were able to launch a product in 4 months, because much of the stack was already built, and we were able to get going in 4 months. So sports was an accident for us, but we had, I think, in a way, kind of destined to get there, because we had everything packaged. We saw an opportunity, and we didn't want to waste time finding yet another opportunity. We said, let this stack be applicable for sports, and got in.
So what are the current problems you're solving in sports analytics other than the video tagging? Are there specific areas you're currently targeting?
So video analysis is the main core, but video analysis is a very deep subject. Like, a lot of people from outside, they don't know how deep that subject is, because it's evolved over the last 25 years, and credit to Huddle and companies like Sports Code, Dartfish, they've been doing a lot of this work. So there's a lot of intricacies to video analysis. So we solve for all those intricacies, like how do you have multiple analysts analyze at the same time? If an analyst is finishing the analysis, within a couple of clicks, how does the data go to the coach, so that there's no time lag between analysis and decision making? If you're a professional team, you'll finish, let's say IPL, right? Your match finishes at 10 p.m. or 11 p.m. Then the players go take some rest, maybe eat a dinner. Then they go to the hotel rooms. Next day morning, when they show up for breakfast, by that time the analysis should be ready. So video analysis requires a lot of workflow management, like acquiring the video, analyzing, we call it tagging, or coding the video. It's not coding, but putting small notes on the video, essentially classifying the video,
Annotating the video.
But there's no drawings.
Okay.
Rarely people draw, though it's a tool that it's often showcased. This is one of the things we learned from the market. It's rarely used, but it's like applying tags, like, okay, this was a 6, this was a 4, or this was an offside shot, this was a leg side shot, right? So then next day you come, the data should not only have the data, but you need all the charts. You need comparison to historical information. You need maybe some sort of beautiful formatting, so that you're dealing with elite players. You should not lose them. They have very short attention spans. Elite players have very little attention spans for such analytics. So our software provides all of that, so that we'd like to think of it as Canva for sports. Like, so Canva did not solve anything different that Photoshop did not already have, but just made it very smooth. For example, all of us want transparent, no background, but we want photos with no background.
2 clicks away.
2 clicks away, right? I mean, so those are the kind of stuff we've done, where we know the pain points of an analyst to get to the coach's session next day. It requires about 60, 70 things to go right. All those 60, 70 things are there as a part of a package.
Cool. So maybe by taking the example of cricket, or maybe taking the example of badminton, can you explain what does your tool help the players do better? What is the impact that is being made there?
Yeah. So what happens, let's say cricket, the flavor of our country, right? So if you take a batter like Rohit Sharma, right? So he's finished his batting, and next day when he comes, right? These days, what they want to know is, how did they play a short ball? How did they play fair against Yorker? How did they fare against balls that came on the offside? Bowled by a certain kind of a bowler. So maybe against all off spinners, give me all the balls that bowled on the offside and how did I fare, and then what sort of things did I do that were correct, what are the things that I did that were not correct, including how did I handle field placement pressures, how did I handle run rate pressures, all of that. So when you're in a team meeting, a coach, let's say Dravid is their coach, and you have Rohit Sharma. There's very little time to go around. When the question gets asked, the answer should be quick. So if the coach says to the analyst, the coach would say, "Hey, please pick all the balls that Rohit played against off spinners. Couple of clicks, you should be able to show all the balls of them playing against off spinners."
So when you say all the balls, is it the video clips or?
Yes, with the clips as well as the analysis, like what was the run rate against off spinners, what was what is the wagon wheel against just the off spinners. So tomorrow, for example, similarly, if we are playing against Pat Cummins and say we want to plan for that, and we may say, okay, give me all the places where Pat Cummins was bowling to a right-hander opener, and where did he get scored against? Like these are the places it's probably easy to hit him. So, but when these sort of data science questions get asked, in other industries, we take some time to recover this data, right? Like for example, if I'm in manufacturing, I may get a question like this, I can come back tomorrow with the answers. But in competitive sport, you're going to play that person very quickly. So you don't have like days to prepare. You don't even have hours to prepare. It has to be instant. So all the software is geared for these sort of instant clicks, couple of clicks, give you both the stats. Okay, if Pat Cummins is bowling to a right hand batter in the opening first 5 overs, then this is the highest region where he gets hit. This is the region you can never hit him, and this is usually he never bowls a Yorker, for example. So you kind of get into the mind of the bowler very quickly and say, you maybe if you're trying to slog against him, know that he may never bowl a Yorker, something like that. So these are the kind of questions that get asked. Similarly, something like badminton, say PV Sindhu is now looking for her match analysis. She's won the quarterfinals, going to the semifinals. She wants to pull the quarterfinals footage of the next opponent that she's playing, and she says, roughly in sports we say people change every 6 to 12 months. So if you played a player 12 months back, it's not very relevant to today's information. So in the last 6 months, players change a lot because they're physically changing a lot, and even tactically they keep updating. So you just very quickly look at not the last game alone, last 3 games. You may say, okay, she goes to the back end of the court. From the back end of the court, how many times can she do a cross-court drop? And then the analyst very quickly checks, okay, or the analyst may have already prepared some notes saying, hey, I see the fraction of cross-court drops from the back court is very low, and this is the data. So if you're ever pushing her there, you can expect that the shuttle is not going to come back here. So these sort of conversations between the player, the coach, and the analyst is kind of the corner piece of how elite sports works. Today, it also comes down to grassroots sports, but in elite sports, definitely these sort of conversations are enabled by software like ours. To do this just with Excel or Google Sheets is very painful. Then it would take you half an hour, 1 hour to answer every query, not in a couple of clicks. So Span and other video analytics software help you get to that answer in just a couple of clicks.
I see. So while you were building the software, the competencies that you would need with respect to computer vision, so were there some things that you had already built back in your time in Aditya Birla, or were those things you picked up while you were building the product?
So even now today in Span, we do only a little bit of computer vision, but one of the key skills we had to pick up was video engineering. Like how do you cut videos, how do you render videos? A lot of people want your videos instantly. How do you serve videos at a very low cost? So that was completely picked on the job. I didn't have that skill, neither did Sham have the skill, and so he architected most of the video engineering aspect of what we did. So FFmpeg, which is the bread and butter of a lot of people's work.
Bedrock of the industry.
Correct. So how do you use it cleverly? All of this was learned on the job. Of course, we had friends in the industry. If we get into such deep trouble, we would call somebody and say, hey, help me out. Or if I hit a certain technical limit where I feel like, why am I hitting the limit? My competitors have exceeded this limit. So is it my architectural issue or whatever, lack of knowledge? So we used to call friends, but a lot of it was learned on the job.
So do you still code?
Absolutely, yeah. I code at least on a good week, I code 2 to 3 days a week, but on a bad week also I have to code at least a day a week.
What's one recent stack you have picked up?
What have I picked up? So recently, I've been dabbling more into text to speech and this whole. I wouldn't even call it a stack. Just APIs. How are the APIs around audio to text, text to audio?
Something like 11 Labs Whisper.
Whisper, 11 Labs. Who's got what? Because some of our clients are asking for such things, and at what price do you even offer it to the client? Because and then how do you architect in a way tomorrow? Let's say somebody is better than 11 Labs comes up. I'm not stuck with one vendor. How do I do a multi vendor architecture? How much of it do I rely on the vendor? So this is the kind of one of the new spaces I've been playing in. And it's actually quite interesting. I think there was a post by one of the senior partners at Axel, Shankar Sivaramakrishnan, I think, has said that the text to speech, speech to text, the whole audio, because in audio, the advantage with audio is once you train a big model on a certain language, it's kind of a ubiquitous use case. I can use it in politics, I can use it in sports, right? I can use it in education. That's not the same for vision. In vision, it's so domain specific. I can't use a vision model for, let's say, sports and manufacturing. So this audio thing is, I think it's coming up very nicely. A lot of use cases are coming, and the APIs are affordable. So that's something I'm looking into now.
So imagine there's a student who just started university, maybe he or she learns Python. For a person like that to come up to and work at BanyanBoard, what would be the set of 5 skills he or she should master in the next 1 or 2 years? Because this industry is changing, your own business requirements are changing.
So we do a lot of data science with pandas. So it'll be good if somebody has good deep knowledge of pandas. We do a lot of data visualization. So we care very deeply about visual communication. That's how we started the company. So we spend a lot of time in thinking about how to get the information to the mind of the client quickly. I may have the data. So I will love to work with people who have strong data visualization skills. So Plotly, Apache, eCharts, even maybe somebody who has some BI knowledge, maybe some Power BI or Tableau, but has that, thinking around data visualization. So that is something we do. We of course do a lot of backend is still Django. So we do a lot of Django based Python web framework work. We also talk to the database through Django. So again, people who are good at ORM queries, all of that. But I think like most companies, we don't let the early career people automatically get into the web framework technologies because it is a little risky. It can bring the whole thing down. So, but I think more than anything, I would love to work with people who are not over dependent on vibe coding because it is a big danger I'm seeing in the new hires. I'm not able to make out their dependency on vibe coding, and quite honestly, I don't know even they are able to make out their own dependency on vibe coding, and their own ability to honestly review their own code post vibe coding is something I look for. Like, are you able to honestly say that I have read every line of my code, every comma or every square bracket, every curly brace? Are you able to explain to me if needed, if you're pushed in a review? I think to me that is the most critical skill, even beyond anything else I've told you.
Strong foundations are definitely something you're looking for. So in your experience where you hire for talent for a cutting edge role like this, where every day you're not only solving real world problems, most of the people out there are doing it, but you're solving at this scale and at this speed. What are some of the challenges you face when you hire candidates? What are some of the drawbacks they have with respect to not only their skill sets, but their overall approach to the interviews, for which many of them may not get an opportunity at a firm like yours or similar places where a lot of innovation is happening in India?
See, it also kind of depends on who we talk to. So we're still a small company. We don't talk to an enormous number of people. But I'll tell you from my experience helping some of the students at Byte Excel through the interview process. I think the biggest challenge I see with candidates is the fear of missing out. So they've spread themselves too thin. So they know a little bit of everything rather than being deep at any one thing. And that translates to a lot of mistakes during the job. And it builds on, and where you feel somehow you're not ready to think critically because, for example, when we had to write a pandas filter, right? You did not have ChatGPT. All you had was Stack Overflow, Google. You did have to think critically about everything you're doing, a little bit more critically about what you're doing. Now, because you have a very addictive system, that's a very able system, that critical thinking is coming down, which is hurting us in code reviews. And I mean, before this, we were talking about this interesting episode where in Cloudflare, somebody DDoSed Cloudflare from inside of Cloudflare by making a mistake in the React use effect, right? I don't know if this was due to vibe coding, but I imagine it could be, right? Because even now, a junior person is not very clear where a Cursor or a ChatGPT or a Gemini fails, as much as a senior person is. So I think it's a great aid for a senior person, but a junior person, because of their inexperience, would probably allow Cursor or ChatGPT to work heavily on memorization and use effects, which is a slightly challenging concept where it can make mistakes deep enough that you can DDoS a Cloudflare from your own self, right? So that is my biggest concern with the incoming crew is, can you be really honest about how much depth you really have in the absence of ChatGPT and Cursor, and maintain that honesty through your work, irrespective of which company you work for.
So, moving forward, now for the last 2 years, there's a lot of hype about generative AI. I myself have been working on agents and a couple of other things. But for someone who is starting off right now, how important do you think it's for them to have some understanding of how generative AI works beyond just using ChatGPT, just the architecture of it, building agents, when it comes to job roles, when it comes to actually building the next products?
I think it's critical because I was helping a very big company recently hire, because some of my friends are there and they asked me to just forward some contacts. And this is a very big company, and they are expecting early career people to help them build agents. I mean, early career, we're not even talking about experienced people. So that's where the market is headed, because agents are, in fact, agents are actually quite simple, right? If a college student is able to build an agent in 4 weeks, it's simpler than full stack engineering, right? So in full stack engineering, I mean, in the absence of ChatGPT, full stack engineering in 4 weeks was very hard, right? Even an amazing student would struggle, or a really well developed responsive website in 4 weeks is very hard, right? In the absence of ChatGPT. So agents are not that difficult. It's just a new way of working, but it's just going to require some practice. So if you are a student who's just starting now, it should 100% be part of your toolkit. Just in 2021, before the LLMs were there, we would tell IT students, you need to know full stack engineering, you need to know data structures, you need to know Python, some amount of data science when you're coming out of college. Now just add Gen AI and agents as another requirement when you're coming out. It's like almost like learning to use Docker or APIs, just another software tool. But without that, it's going to be very hard, because because it's
Part of the work.
part of the workflow now. Yeah.
How much of agentic AI do you use in your company at the moment?
We don't have any customer-facing agentic AI. I mean, of course, we use Cursor for coding every other day, but nothing customer-facing. And that's kind of intentional decision, because we don't have that sort of client requirement yet, and we're also very careful about building only things clients will use, not testing. We're bootstrapped and we want to stay that way. So not yet. Yeah.
So you mentioned your backend is on Django. As someone who is building a product and you're bootstrapped, you might have a team who is also handling the backend. When you get recommendations like, let's shift it to Go, let's shift it to Express, something in Rust, which will be much more faster. How do you take a call on that?
See, that's a really good question. And see, it's very simple. If you run your own company and you know that you don't have the money to keep just switching stacks, and it's just not the cost of the switch of the code, it's also the cost of maintenance. And if you ask a scientific question, what is the value of the switch? It's very difficult to get a really good answer. Yes, there is proof at maybe planetary scale or really massive scale, Go and Rust would work. The reason I took Django as a call, my brother had not worked on Django, neither had I. In my company in Aditya Birla, somebody had worked out Django, and I would just go to every client demo they had, and they had no problems answering what clients wanted. I said, if that's the case, right, then I should be able to work with it. And my brother's company had built their own web framework from scratch, because they had actually started building when Django itself was not very popular. and they just refused to move to web frameworks after that because some historic decision making at the leadership level. So he also seen the problem of not having a web framework. So his point was, let's have some web framework. I had seen one web framework work, which is Django. So these were 2 data points we had. The third data point we had was, at that point we were just reading, okay, what should we choose? Django? This was a big question, right? And then Kailash Nath, who is somebody I admire a lot, he's the CTO of Zerodha. So whenever he writes something or says something, I try to go and listen to it. Kailash, if you're hearing this anytime, thank you very much for your guidance. So he had written, or maybe him or one of his teammates had written a beautiful article in Zerodha saying that, if you have like just 1 million customers, and he said just 1 million customers, you don't need anything more than Django. I said, wow, I'll be very happy with 1 million customers. If Kailash is saying do Django, right? Then what's the point? So that's the amount of research we did. Now when somebody says, why don't you do Express? No, I've done more work in Express as side projects. We've not built it in the main stack. I do wish, okay, maybe I could have started a Node. I didn't understand the idea of Node being, even though it's single threaded, it's very good with concurrency. Fundamentally, I didn't understand the words single threading and being still good at concurrency, and where Django really struggles with concurrency. We are hitting up against those limits for sure. But since we know other ways to work around it, we have our workarounds these days. Maybe someday, for example, today when we get a sudden ask for anything, we write it largely in Next, or we will write it within the MERN stack, and we host it as a separate server. These are tiny use cases. We don't know whether it's ever get productized. We don't want to start from scratch from Django or Fast API, because we are very comfortable now with the MERN stack and in Next, or we may even do an Electron app, right? But I still would not touch my main master product, because my master product is too sensitive, right? So I think, to your question of how do you take a decision, I think all of us have that internal compass on whether this is useful, but some of us techies sometimes get over excited by tech and we move into something new. I have done this in other things, thankfully not on web frameworks, and not spent that much time, but we do get a little excited on tech stuff. Like, just for fun, we built something in Tori, even though we had no background in Rust. Just, what is this Tori? Everybody was building in Tori. Let's just build it. Let's build one. And suffered like hell, right? We couldn't understand the code, and everything was cursor based. It was like hell. So we said, okay, never again. After 2 times, it's okay if my package is, 2x bigger, 3x bigger. I would rather stick with Electron stuff I understand. So I think largely if techies are honest to themselves and are really honest to the amount of money they're spending versus the business case, you can come to the optimal decision.
So the next question I had is, nowadays there's a craze among students that, like, how they prepare for DSA, they also prepare for system design, right? Now, system design is a ocean by itself, right? Even at this age, I'm still learning. I have systems for clients here and there. So as someone who is actually building systems and serving clients at your scale, how much do you think students should be focusing on this subject when they're starting off at their career?
See, I'm a proponent of learning some system design, so that when you don't go into a company and make huge mistakes, even DSA. But we know there's a lot of, you go to Hacker News or Reddit, you'll see a lot of instances. I don't think people are lying, where you're hired through a DSA system design exam and you're doing React front-end coding, right? So I think some of it is just fad. Like, you're worried, right? You're just worried that you should not get excluded from a job interview. And some job interviewers also probably drive this fad because they just don't know any other way of hiring. Sometimes, you don't even, when you're interviewing for a job in a big company, the person who's recruiting may not even know where you're going to get placed. They're just going to take a few skills and check it out, right? But I don't think for me at least, if I was hiring in BanyanBoard, it's a showstopper at all. I would rather teach them the system design we do, rather than having them learn some generic system design that works at planetary scale that's not going to work for us, and just help them after they join the company.
So in the machine learning part of the work that you do, I was interested in understanding, how do you decide performance metrics? Do you even do that? Is there something evals that you do? How do you come to that?
It's a very interesting question. In fact, a lot of people don't ask this question in machine learning. I think that's where business happens. See, each business has its own thresholds of what is accuracy, what is precision, and learning that comes from only being in that domain. So we are in the domain of doing sponsor analytics for a lot of companies, and the hardest thing we've learned is, what is good enough in accuracy for a client. And so if somebody is trying to get into any domain, manufacturing, right, if you don't know what is good enough for the client, you can keep over engineering, and especially the last couple of percentage points in machine learning are the most expensive percentage points to overcome, right? So I think that just comes with domain knowledge. And if you're in that domain, because we're in the sponsorship analytics domain, we know what is good enough, so we can stop instead of over engineering the models and killing ourselves on cost while keeping the client happy. So there is, I think this is a subject matter knowledge question where you need to know that domain very well. So it goes beyond machine learning. You may have, if it's a big company, you have a machine learning engineer and a domain expert. The domain expert should bring that. But if you're a small company, it's really important to stop machine learning for some time, sit with the client, figure out what is good enough. But otherwise, you over engineer, it becomes over expensive, and you're not going to be profitable.
So our next question is more on the job side of things. I'll come from my own experience. When I started machine learning, it was an age when PyTorch was not there even. If I could just build a simple convolutional neural network, have a multi-class classification, I had a job. I had multiple jobs, right? So that was what was needed, right? I even didn't needed to know what's happening behind the scenes. TensorFlow more or less was enough. I needed to know what's max pooling and all of that. But now I think things have changed. So for a fresh graduate who's interested to do something in the analytics domain, right, what is the depth that they should go into?
So let me take computer vision as an example, right? And also maybe take time series as an example. These two places I understand. I think if you're doing something like computer vision today, you should be able to first use models, right? So you should be able to use a YOLO, you should be able to use a transformer-based model, understand the constraints during training, how do you annotate, run inference. If you're able to do that, then next level, understand architectures. And maybe you cannot create your own architecture, but can you at least code up a known architecture? Right? Okay, I'm giving you the YOLO architecture. Can you code it up? Can you at least know what are the matrices, what are the shapes of each matrix in each layer? Because, for example, even you're sitting in a team meeting and somebody draws an annotation on an object and you're trying to do a decision on, there are two objects that look very similar to each other. Let's say I have a mic and you have a mic, and we have to detect, is this the mic on the left side or mic on the right side? If I just annotate this mic and your mic, then the discussion goes in on, will it be able to capture the left mic versus the right mic? What should we do? And then the discussion goes into, hey, does the model take into account the surroundings? How much does it take into account the surroundings? How does it do it? So the next level discussions during slightly complex problems needs you to know the architecture. Otherwise, you're just going to be an annotator and you push the button. So I think if you're a machine learning and computer vision person, you should be able to build out an architecture. So see, which data, the neurons are going from where to where. Is all the data getting used? Is only the annotated data getting used? Where are the pixels coming from, leading to the output? Similarly, in time series, for example, if you're doing time series forecasting, let's say multivariate time series forecasting, you are going to end up using a lot of regression models. And in time series, the biggest problem people have is they end up using future data for prediction, which is not allowed. And this is like, even professionals do this. You're supposed to use only historic data to make a future prediction, but you end up often using future data, and everything becomes a big mess. Now, again, if you're a student there, you don't want to just run, there are a lot of packages these days. You give it, it'll run 5 time series models, give you an output.
Facebook Profit, I think, is one.
Right. So if you do that, you're doing a disservice to yourself as a student, because at that point, anybody can run Profit, right? So if I were you, I would look into at least what is the algorithm behind Profit, right? Can I hand code that algorithm and deliver this? I'll just share one example from my own life where I felt this was the aha moment. We had to simulate an electron diffraction pattern. And I just thought it was impossible to do. I thought it was things only my professor level people would do. And we had a piece of software in our lab which is too difficult to use. It is Linux. It had 10 steps. And I had very little time. So I decided I have to recode this in MATLAB. But because MATLAB I had the GUI and I could go faster. But the physics, how do you, it's like the convolutional neural network. What are the layers? How do you have the physics of the electron interacting with the atoms and producing a diffraction? I just looked I was talking to one of my friends who wrote the Linux piece of code. He just showed me, hey, this is just 3 lines, Shankar. This is just 3 lines. Look at this is how the electron interacted. How come you don't know this? This was the first thing the professor taught in the class. He did teach it in the class. I never thought that that is how you would code it up. It is 3 lines. So often things feel harder than and then I was able to translate it into MATLAB very easily. But that critical piece of knowledge, right? So we sometimes, especially students, may think a YOLO architecture is too difficult. I can't do it myself, or a Prophet is something that's too difficult. That's not true. I think arriving at that architecture after doing thousands of trials is difficult, but understanding the architecture and rebuilding yourself is not that difficult, right? So I would encourage students heavily to at least go execute what you've done by yourself. Like take PyTorch and build it out yourself, or take PyTorch, do a transformer model entirely end to end by yourself, right? So that would be the level at least I would suggest a student should go to.
So at the moment, in the market, there are thousands of courses just on machine learning. There's books out there. There's different firms doing a lot of stuff. There's NPTEL, which is doing a great job. But you would have noticed that there's a lack of talent when it comes to, let's say, just the data science place, the machine learning place, software as a large. Let's focus on one area. So what is something that's missing in the educational sector, which is not directly getting translated there? Because what I've observed, a lot of the successful folks in the industry are people who are already successful somewhere. Let's take your example. You are already successful in material science. Then you picked this up as a skill, and you again succeeded in this. But a lot of the people who are getting into the industry, they're not able to do it directly. So is there something in the pedagogy? Is there something in how they're learning or what is being taught to them that could be changed?
So there are two aspects. Perhaps in what you're teaching, I do sense there is a lack of number of teachers we have who understand stats, who understand coding, and who understand latest machine learning technologies. I've seen this in the private engineering college spaces. Even in the IIT and NIT BITS levels, you have, no professor is good at every one of them to build out like a full machine learning stack. But I think I should also caution students, right? Machine learning is a deep science. It's like, imagine becoming a doctor. You cannot just come out of 4 years or 5 years of MBBS and become a doctor. So because machine learning does require domain knowledge. So if you're doing machine learning for healthcare, you should have some depth in healthcare. Or if you're doing it for e-commerce, you should understand e-commerce or material science, right? So it does require expertise so you have to dedicate time if you want to be an expert. So you come out of college, you may know the basic techniques, then you get into some domain, sports, right? You become good at sports for 3, 4 years, 5 years, then really you can show the power of machine learning in sport, because no one's going to, anything that is obvious, somebody has already done it, right? So you have to find something that is non-obvious that will take you 3 to 4 years. Then you drive your interesting machine learning algorithm into it. Then you come out with something like a doctor, right, who comes out as a brilliant person that you trust your life with only 10 years later, because there's so much complexity in the human body. I do sense you can just crank a button and do some machine learning, but if you want to do something that somebody else has not done, you need, I think, post-bachelor's, at least 5 to 6 years of domain experience in any domain to do today if you want to do something novel.
I see. So as we are seeing the advances at such high pace in the industry, specifically in generative AI, but overall as well, which are the secondary outcomes of it, how do you think the Indian job market will look in the next 1 year? I'm not even going 10 years, because even for someone like me, I see roles like AI governance, there's an AI product manager, not just focusing too much on the AI part itself, but the skills themselves have changed. So how should students prepare for this?
So one thing I would advise to students, for example, is do be prepared a little bit for a reduction in salaries, because AI has made a lot of things doable by others. So for instance, we have not hired some developers we wanted to hire. So be mentally prepared. Software developers, I don't think will continue to earn this high premiums they have been charging so far, because what they did was special. Now a doctor is able to do a website development, right? So one of my friends who builds websites said, what could be a $350 website, WordPress website today is only $60. So, 1/5, right? So one is it's okay to be having a slightly lower salary, because, the market will correct itself. But I think in terms of the other roles that appear, like you said, there could be an AI product manager and this and that. I'm actually very poor at forecasting these sort of things, but my guess is overall, I think the industry will balance. because some things that are now getting done by AI, there's a lot of things we've not touched. Those things will come in, and we're going to get a larger scope of things solved by software. AI just being one aspect of software. So I think students, but I think if you're a student, a lot of additional domains if you can pick. If you're an interest in economics, pick economics. Finance, if you have an interest in engineering, mechanical engineering, pick mechanical engineering. And many people who have the option either of picking a mechanical engineering or electrical engineering and computer science, I mean, unless you're super duper passionate about computer engineering, web development, now probably it makes sense to learn electrical engineering, mechanical engineering, and a minor in computer science, or do some external courses, so you don't miss on the developments of data science. But I think the domains, like for example, computational work for machines, like control systems which control machines, is not something AI is still heavily worked upon, right? So it will get there. So would you want to be a part of that? Maybe you want to be a part of that revolution.
So something from your own LinkedIn profile, which is you have a lot of patents, right? Which is a accumulation of a lot of good R&D work. So now that you are leading a business, you hard code a product which is out there in so many places, and you are scaling up. So if you were to talk to your younger self, would you have still given the recommendation of go down that research path and see what it does, or exit early and build products?
I thought about this a lot. I think given what I was exposed to, I don't think I could have done anything differently, because given my exposure. But I do think I could have spent my weekends more meaningfully. When I was a PhD student, we would work 5.5 days a week and then take it light. I wonder if I could have at least explored what is products, not even software products, any product, because I didn't have any inclination to start a business. So that is the problem. But the biggest advice I give to my younger self, and therefore any poor soul young self who comes across me, is don't waste your weekends. The weekends are your time. Start exploring about ideas. It could be, why didn't I invest in markets when I was 25? Why did I wait till I was 35? Why didn't I even think of product market fit till I was 38? Right? These are things I could have thought of earlier. It just that I was probably happy, but I did play a lot of sports over the weekend, which is probably helping me now. But I think there is a lot of time available in weekends one can use. I think that's what makes great entrepreneurs who they are, because they take those weekends, they take them very seriously, and they push forward ideas. A lot of those ideas I wish I got at 38. I wish I had them at 28. But some things you can't force. Maybe if you start working hard on weekends, don't waste them. Train yourself somewhere. Just go talk to businesses. If you're interested in entrepreneurship, what do you guys do? Or if you want, whatever it is, right? Develop some useful work on the weekends, then I think something may come out of it, is what I would tell my younger self.
So now that I understand your experience and your journey, how you have been, so I want to know, how do edtechs like us, like ByteExcel, if you were a student, what can we do different so that the Shankar who was back then doing material science, he can directly jump into something innovative where his efforts can translate into revenue, can translate into actual impact in the world? Because I think this is a gap we would like to solve as a company.
Yeah, see, I think where edtechs can really help, perhaps, especially in where we have tier 2 colleges, where we are seeing 74% of the students are first-time engineering graduates. The parents have never done engineering, is exposure. Like, I've seen, talk to ByteExcel a few times. I know that I was really shocked to know that several of them are aspiring to have GitHub repositories. Like, I didn't even know what was GitHub till like 5-6 years back. So exposure, right? Explaining to them what's the art of possible. It could just not be in tech. It could be even personality development, your ability to handle interviews, finance, entrepreneurship. Even if you're looking to do business management, right? Whatever. So in a way, edtechs, because you're working so deeply with the student, you have their mind. They will listen to you, and they are looking for exposure. One may argue, what do you mean exposure? They have a YouTube, they have the internet, everything, right? But now we have already reached the point of overexposure. Like, they're anyway consumed by things that flooded by. Right? Now it's not going to help them. So if you have a very systematic way where you're exposing them, I remember we bought some students from ex-engineer at Tesla, and we had them speak to some of the ByteExcel students, where the idea was, they may think I'm working so hard and I may get only like a 5.5-6 lakh job. But somebody from Tesla is coming and explaining to you that if I work this way, that way, I may probably be an engineer in Tesla or Facebook or whatever. In India, for us, Zoho and Freshworks and so on. So the idea of having exposure, right, I think is something really techs like Byte can do. And it's not just about tech exposure, because you have access, you can send newsletters, you have 150,000 students who will read it, right, because it's coming from you. And those students are going to be exposed to this like dialogue about, is vibe coding evil, right? How much Python should I learn, right? What is entrepreneurship? So how many students from Gujarat who were not in NIT or, IIM started companies last year? Right, and that's going to be very inspirational for a student from Gujarat, right? Similar, so you have, I think, enormous potential to do that sort of influencing, because you have this massive pool who's also super hungry, and their hunger is what one of the biggest reasons I started my company when working for Aditya Birla. The hunger around me just astounded me. I said, if you have such hunger in the country, all you need is some decent company, and then the rest of it will take care of itself. So I think you can really stoke that hunger by giving them the right kind of input.
Definitely, I think we would be moving in that direction, and we'll again connect back on that once we are there. So before we end this, I would like to ask you, what are 3 things, both on a professional side and on a personal side, you look forward to experience or learn in 2026?
So, as a company on the professional side, we're really trying to become a stable company. We have 3 products. One is video analytics, one is broadcast graphics. Now we're looking to sponsorship analytics. We're just looking for deeper product market fit. So on the professional side, we're trying to get there, and getting better at sales, getting better at marketing. Tech, we're not that worried, but getting better at other aspects of running business. And I am also looking to become better as somebody who's managing a company myself. I want to dedicate a little bit more personal time to working out, or just being a little fitter than just constantly working all the time. And that is on the little bit of the personal side. And of course, spend more time with family. Once you're running a startup, it kind of sometimes becomes all consuming. So I'm hoping now that we're finishing the 5th year, I'll be a little bit more mature in how I handle my time and my, stress and all of that. So I'm really looking forward to becoming a better version of, somebody who runs a startup, so that it's a little smoother. Otherwise, you feel constantly you're on the treadmill.
So with this, we end this episode. Thank you, Shankar, for joining us. So with this, we conclude the current episode of Beyond the Byte. See you guys in the next one. Bye-bye.